Hello everyone, my name is Jared, and today I will show you this Physics 260 problem. This is from the final in fall 2009. Number 2. A block of mass m is connected to a spring with force constant k. The mass is free to oscillate on a horizontal frictionless surface. Suppose the block is displaced by an amount a from its equilibrium position and then released. Part A asks, what are the position, velocity, and acceleration of the block as a function of time? Part B, if m is equal to 200 grams, k is equal to 5 newtons per meter, and a is equal to 5 centimeters, what is the period of motion, the maximum speed, and the maximum acceleration? So the solution, first we should write out what variables we actually know. The problem gives us the parameters m, k, and a. And what we want to solve for are the three functions of time, x of t, v of t, and a of t. And then with the known variables in part B, we need to find the period, maximum velocity, and the maximum acceleration. So we can assume that the horizontal friction of the surface ends on an ideal spring. So here's our diagram. You can see that the block is connected to the spring. It has a K, and the block has a mass of M, and it's displaced by A. And from this diagram, you can see that on the horizontal component of forces, that when it's at equilibrium, really only the spring force acts on it. So we don't need to worry about an applied force. So our analysis will start with the equation given to us, that we already know that the position of a block on the spring is x of t is equal to a times cosine of omega t plus phi. And in this scenario, phi is equal to 0 because we don't know of any phase changes. And also, we know that the angular frequency, when it's squared, is equal to k over m. So that means that omega is equal to the square root of k over m. So now that we know all the variables we need, we can say that x of t is equal to a times cosine of the square root of k over m times t. To get the velocity function, it's simply the derivative of what we previously got. So we have to take the square root of k over m outside of the trig function and turn the cosine into a negative sign. So v of t is going to be equal to negative a times the square root of k over m times sine of the square root of k over m times t. And just like previously, acceleration is the derivative of velocity. So again, we have to take out that square root of k over m and turn the trig function from negative sign to negative cosine. And since on the outside they're both square root of k over m, we can square those together to simply just get k over m. So the acceleration function will be equal to negative a times k over m times the cosine of the square root of k over m times t. And then later in the problem, we're given that mass is equal to 200 grams, k is equal to 5 newtons per meter, and then a is equal to 5 centimeters. Now it's best to convert in the beginning so that you don't mess up along the way. So we can get that mass converted is equal to 0.2 kilograms, and that a is equal to 0.05 meters. So they want us to find the period now, and that's equal to 2 pi over omega. And we already know what omega is, so we can rewrite that as 2 pi is equal to square root of m over k, since this is the reciprocal of omega. And if we solve with what variables we have, we can get the period is equal to 1.27 seconds. Now to get the maximum velocity, we know that it's maximized when the sine function is equal to 1. If it's anything different, then the velocity will be lower. So we can take the expression in front of the sine function, and we can set the absolute value of it since we just looking for the max speed. And then this will be a times the square root of k over m. And then plugging in our values, we get the maximum velocity is equal to 0.25 meters per second. And then the same thing is applied to getting the maximum acceleration. This is when the cosine function is equal to 1. So we could take the expression in front and have it be a times k over m. and plugging in our values, we can get the maximum acceleration is equal to 1.25 meters per second squared. Thank you.